Okay, now we talk about how we can determine these values TD, TP, TR, TS, and percentage of the mu s, percentage of mu s of the second order system. Before we go to that step, let me show you. This is the response of the second order system. So in this response, you can see that this actually, you can see that this is the response. Okay, usually the damping system is like that. If you remember from your SPM physics book, SPM physics, the damping was like this, right? So it is like this. So the damping, this is the first. Okay, then this is the actually peak, the first overshoot. This is the peak one. So we consider here, because this we consider this line as a 1. So this one we consider as a 1. Okay, this line is considered as a 1, and this is the first peak. And of course this x-axis is c of t, because it's in time domain, you know, and this side y-axis will be the c of t, and x-axis is the t. Okay, now if let's move forward, we'll come back to the response figure later on. So what is the time delay, TD? Time delay is that the time required for the response to rise from 0% to 50% of its final value. So that means that the required time for the response to rise from 0 to 50%, so of your final value. So my final value is 1. So 50% of 1 is 0.5. Okay, so let's approximately this is 0.5. So from 0 until 0.5, so this area, this place will be our time delay. Okay, so what is the formula for the time delay? The formula for the time delay is TD equal to 1 plus 0.7 zeta divided by omega n second. How we derive the derivation of the formula is already explained in your slide. Okay, later I will send you the slide. They will understand. It's not actually difficult, but most important thing is you need to remember the formula. Second is the rise time. For the rise time, which we call it, you know, rise time, we call it TR. So time required to the time required for the response to rise from, there are 3 options here. Number 1 is if it is from 0 to 100% of its final value, then we call it underdamped system. If it is 5 to 95% of final value, then we call it critically damping system. If it's 10 to 90%, we call it the overdamped system. So for all the system, our formula TR will be pi minus cos inverse zeta divided by omega square root of 1 minus zeta square. Unit will be second. So this formula is for the TR. So TR, if we go back to now graph, where is your TR? TR is this. So in this case, we consider actually 1 until 1, because 0 to 100%. 100% is 0, 1. From here, that's from 0 to 100%. This time we call it TR, the rising time. Next is peak time. The time required for the response to rise from 0 to peak of the time response. That means from 0 until the peak of the time response. So we can go back to our response diagram again. This is the response diagram, remember. This one we call a response diagram. So this is our peak. As I say, this is our peak. So if this is the first peak, so we call it this is the first peak, or we call it the first overshoot, or also we call it first maxima.